So is this the order to start, sorry? Everyone can listen? Okay. So I will start. First of all, thank you for the opportunity to be here today. What I would like to do is actually to share what I do in a particular course of our Masters in Food Engineering that integrates for the past few years the environmental issues. So I'm actually a food engineering myself, and when I was a student, there were no issues that were talked about, or at least very explicitly in our programs. And we have been doing this for at least, I think, 5 or 6 years. Actually, this now would be compulsory anyway from our accreditation agency to have the environmental issue course on the masters in our food studies. So when we were told by our agency, we are actually already implemented that, which was always something we wanted to do, because for many years we had the course on environmental engineering. So I'm a food engineering, but I always went through the path of the environment. So that's why I do this course. So this is basically it. Not many expectations. It's just to share what I do with the students, so they get the awareness of these issues. Not to be environmental engineers, but to know how to deal with this, because this is something that all the areas, all the sectors have to integrate in their professional lives. So I start with the sustainable development, that everyone knows the concept, at least that we're talking here now. And when I said I was a food engineering, and we did not talk about this. In 1987, I was almost finishing my degree. So it was at the time that no one would talk about this, and it was given just to the environmental engineering courses. So in fact, what I do when I start with the students is to do a poll, because they are doing the master in food engineering, to ask whether, well, most of them know me, I should be there and there should be a course on it. And during the past few years, the number of people that raised their hands in terms of saying, no, you should not be here, are decreasing. So these issues are something that the students want to hear about, and are more aware of that. Because before it was like the environment is something else. So this is a course for environmental engineering students who have to deal with treating what we do not do right. And even in secondary school, environment for many years was separating the garbage. At least in Portugal, I'm giving you our experience in Portugal. So the environmental studies decreased a lot in terms of number of people interested in doing environmental science or environmental engineering, because they were mostly related to that. And what I do when I start is always showing some figures to give this awareness of the importance of what I'm doing, or what we're doing in the course. So there's the Earth Overshoot Day that every year is released. This year, the Earth Overshoot Day, or it means when we already spent the resources that we have, was on the 22nd of August. It was something that was coming through with an increase steadily, but this year, and this is because of mainly the pandemic situation that led to a reduction in the economic activity, we have more Earth to live in. I mean, the Earth Overshoot Day was delayed to the 22nd of August, but we only have one planet, and at the moment this year, it's like we needed 1.6 Earth to be on the planet in a sustainable way. So it's not still it's not sustainable. So these kind of figures help the students to look at it in a different way, to look at the environment. And it's also important from the start to say that this has to be looked differently in different countries. So the overshoot day is not the same for all the countries. And it depends on the industrial activities, economic activities, or environmental practice that each country has. Here if you go to the site, you can see all of the countries. I actually looked at Armenia, and it's quite towards the end of the year. So you do, in terms of environment, you're doing quite well. I didn't look to all the countries, but like for Portugal, it would be like May 25. So we're not even in the 22nd of August. So this is something that in the studies of the food studies have to be incorporated since the beginning, these issues, because the food industry and the whole food chain from agriculture to processing has to be aware of this and do the growth in a sustainable way, and not exceeding the capacity of the earth to replace them, which is what we're doing at the moment. And the whole course goes in a way to show that the food sector suffers with this, because if the temperature rises, of course, agriculture is going to have problems in different parts of the world, but it's also the food sector that contributes mostly to the degradation of the environment. And we have to eat. So we'll never, that is something that we always have to do. We just have to do it in a different way. Something that I really like to do also, and I left this picture from the 2nd of March. It was when, as I was preparing a course that I give to an international master on environmental issues, a course that is taught every day in March for 3 weeks. And I always go, when we start the course, let's go and see what the Earth Observatory image of the day. They always put an image for the environment. And for example, in the 2nd of March, the image of was the decrease in the amounts of nitrous oxides that were released due to the pandemic. So I think this really integrates the economic, social, health, all the areas that have to be put into this global issue of the environment. So the environment is just not for the people that study the environment, everything is related. I actually, 2 days ago, I put these slides together and I looked to see what was the image of the day. This was on the 2nd of September, so it was on Wednesday, and it was a global water hyacinth invasion due to urbanization that was taken in Mexico Valsequillo Reservoir. And this shows, this is due to nutrient leaching in the reservoir, and it shows the importance of, say, not polluting the water streams. At this time, this is really a problem, and it will bring later on the issue of eutrophication due to, for example, the high input of nutrients that are also caused not only from the wastewater that is being released by highly urbanized centers to the untreated, but also to agriculture activities, which is much more difficult because it's what we call diffuse pollution. So these images sometimes are very good for the students to immediately see that how important and how global the problems are. And then we go on about, this is a 5 ECTS course. So what I'm doing today is just to show the overall picture, because the students need to be aware of what the course is going to be. I go on to the population growth, climate change, deforestation, global warming. So all these issues, loss of biodiversity, all these issues are approached during the course with a strong relation to the food systems. And also, from the beginning, we go into what we use as the planetary boundaries. This was a concept already from maybe about 10 years ago, just 11 years ago, that were released, and those are fixed in a way that if you do go above them, you're in trouble. And it shows there are two, the biosphere integrity and climate change, which are key to the whole process. If you go above them, then you're really in danger. So they are like pillars. All the others also have their boundaries, but these two are core. And if you look here for biosphere integrity, you could think, okay, then we're really bad because we're already went past the safe level for the genetic diversity. It is true, but this is not always linked to the functional diversity. I don't know if whether you see the pointer. Do you see the pointer in my screen?
Yes, yes.
Ah, okay. So this is not yet quantified. And of course, genetic diversity on its own does not say much, because we need to know the functional diversity. What does it mean not to have such a high biodiversity, either below ground and above ground? In many cases, these two are still not related, but there are other boundaries that are being already overpassed, which are the the nitrogen input to the ecosystems, the over leaching of nitrogen, and we do not look at nitrogen on its own. It's nitrogen and phosphorus. Actually, if you think back of the hyacinth picture, it was something to do with the leaching of nutrients into the ecosystems. So we need to have in all sectors to take into account that we are responsible for this. It's and the food systems are no exception. So this is like the beginning, and we all know that climate is changing. This is not a course on climate change. If you just type, maybe I typed this maybe a couple of years ago. I'm not sure. I do it then with the students together in class. If you just type food production and climate change, you see a whole bunch of buzzwords on what's happening, on how climate change threatened the food production. This is really a thing. But in this course, we also look at how food production is threatening the climate change. So this has to be done. This has to be looked at in both ways, and there is a lot of things we can do. We know that greenhouses are increasing. You can just grab a diagram from the internet. The CO2 levels are increasing. We always look at this in terms of CO2, but when we're talking about the CO2 levels, then we have to take into account all the other gases that are greenhouse gases that have this capacity for the greenhouse effect. And we have to look into methane, the nitrous oxides, like you've seen in the first image of the Earth Observatory in China, and the fluorinated gases. And these three are much more potent than CO2 itself. It's just that they are in much lower amounts, and then they contribute less. This is actually their contribution for the global warming. But all this is also related to food production, and especially the methane comes, in fact, mostly from biotic emissions, especially ruminants growing. So we look at CO2, and most of the data you find is in equivalence of CO2, because then you translate the figures all into CO2, but you have to go look into all the greenhouse gases that are together with that. And of course, temperature is rising. I picked this diagram. You can pick a lot. They are not all the same. There is no agreement, but there is a tendency for the surface temperature to grow, and this will affect food production, of course. And just to have a brief overview of course, the different food sectors or food production of different say commodities have different impacts in the environment. And clearly, if you look here, you see mostly the ruminants. If you are working within this area of meat, the greenhouse gas emissions, the impact is much higher than if you're looking at sectors like fruits and vegetables, because we're not looking just at the processing. When we look at that's why we call it the food chain, we're looking at the whole thing, and not just the food industry itself, but also the growing of the meat. And of course, this is related then, that's how people can do all these graphs that relate, for example, your diet with the greenhouse gas emissions. If you're a vegan or if you are a meat eater, these of course are gross figures, and they don't always, they don't mean the same. These are average values. They don't mean the same in all the countries. This is very much depends on the location. If you are a vegan in Portugal, but you are importing all your food through aircraft from the other side of the world, maybe your impact in the environment is higher than if you're eating the cow that is next door. So this is actually difficult to look at, because there are so many issues related to this. It's not just the food you eat, is where it was produced, how it was produced, how it came into your plate, where did it come from? So these issues of sustainability are not very simple to approach, and it's not easy to say it is the same in everywhere you are. One thing is true, we have to eat. The world is, the population is increasing, and we have to produce in a climate change scenario. And this is really the fact. So you have to look at producing in different ways, because we just have one planet. And I always like to hear these people that are from global data, that do consulting services, and sometimes from their presentations, they just present the trends in food industry. And the one from last year, 2019, I heard them, I think it was around this time last year, and they were putting up what are the major challenges that food industry faces. And together with the economic uncertainty, I don't know whether the issues will be the same after the pandemic, but if you look here, for all these issues, the second one is the environmental degradation. This is actually an issue for the food production. If you do not have water or soil, you're not going to produce. You can have your factory, but if you can't produce, if you do not have the primary production, you're not going to have the food that you need. So environmental degradation is very much an issue for food production. Of course, it's not only the water, the soil. It's also the temperature is rising, so you have to face agricultural productivity in a different way. Everything is linked, so it is a big issue. And as I said before, probably this comes now, but I already said, it's also that although we're facing the environmental degradation, agriculture and food consumption are the most important drivers of environmental pressure. And this is a fact. We're causing land use change, biodiversity loss. We contribute to climate change, water scarcity, pollution, degradation of the soil. So this is a two-way thing. It's not just a unidirection that we have. Poor of us, we have to face the environmental degradation that others are doing. No, we are doing it. We as people involved in the food systems. And if we look, this is a very nice, I always live here, where I'm taking this from. If we look at this publication, assessing the environmental impacts of consumption and production, and you look at this table, on top, you find the food and beverage sector contributing to what we call the environmental impacts: abiotic depletion, global warming, photochemical oxidation, acidification, eutrophication, ecotoxicity. If you see the impact that this sector has in comparison to others, even to transport, there is no figure that is actually higher in transport than in food and beverage. So it is something that we have to face. We contribute to that. It's not that we're not going to say we will stop contributing. That is impossible, because if we're producing food, you're always going to produce CO2. Is that we can do it in a different way. And there are these key pressures that have been identified related to the food systems. One of it is the population of growth, or the growth of the population, let's say. The other one is food waste. I think this is more the food wastage, because it includes food waste and it could include food loss, which is, depending on what we read, between a third and a second and half of what we produce. Is just changes in the supply chain, which is more demand-driven, supply-driven than the demand-driven. Water, phosphorus, and biodiversity loss. These are actually the focus, and I'll just go a bit into each of these, relating, of course, the environmental pressures to the food systems. So sustainable food, which people are talking about, it's not just about the food. It's not as easy as I was saying, we are vegans. It has to do how the food is produced, how it's distributed, how it's packed. I will not go into packaging in this webinar. How it's consumed. So all these contribute to sustainability, because you have the food miles for food, how far a food has traveled, not just how far has traveled, how has traveled by boat or by aircraft, how you do your agriculture practices. So all this contributes to saying that we are sustainable in terms of using the food. And FAO has put forward this food system wheel that incorporates the economic, social, and environmental into the wheel, and not just the food. I think this is quite an interesting, if you want to look at it afterwards, is quite an interesting way of looking at it. And it's also based in the Sustainable Development Goals that everyone knows, the 17 goals that you probably all heard about, which on their own, I don't think mean much. This is very personal, this opinion, because it's very difficult to just look at one goal and think that it is separate from the others. You can't. How can you separate water and energy? You need water to produce energy. You need energy to produce and transport water. You cannot change one of them. You cannot improve or worsen one of the Sustainable Development Goals without having an impact on the others. So all these are related. On their own, you can't just look at them separately. So this, in terms of the food systems, we all need to survive, and we all need the natural resources to survive. So that's to produce the food that we need to survive. So that's what we look at in this course: air, water, soils, mineral, fuels, forest, biodiversity. We have a whole semester to look at this, and this first part is just to get to awareness of this. For example, I'll just do two topics more in a bit more detail in this one. Water. Water, it looks like we have a lot, but we only have less than 1% in the planet that we can actually use. And it's not the same in everywhere in the world. Lots of images on that. Some countries have the water, they do not have the resource to get it from the underground. some do not have, although they are more technological developed in other aspects. It's just not the same everywhere. And it's a lot of people, millions of people do not have access to potable water. And lots of people still using drinking water contaminated with pathogens, microbial pathogens. So this is still happening. A lot of people do not have access to water. The availability of water is declining everywhere, especially of water that we can use. And still, we actually are wasting a lot of water. I give the example in Portugal. We are doing a lot better, but even for fresh water to Porto, the water that we get in the tap, maybe 10 years ago, 15 years ago, this is something like you can think, how is this possible? But 60% was lost in the pipes. So we're producing water and we were wasting more than half just through the piping system. And it has to travel for about 30 kilometers. If it was a straight line here in Port where it is produced, it's not a straight line. It's kilometers of transport, it's pumping, it's energy, it's a lot. And we're wasting it. So we're wasting energy after all. So sometimes it's very difficult. I have webinar on water, which is my main issue. So today I'm not showing any research, but it's like, it's very difficult to say to someone, don't waste water. Water is scarce and it rains for many months. If you say to them, you're wasting energy, maybe you get a different response. I don't know, this is nothing very easy. But the issue with water for the food production is that if you look in green, and I'm sure you're mostly aware of this, where do we consume your water? Mostly in agriculture. Overall figure in the world is 70%. So, and it's not like we're saying we can expect this to lower a lot, because we will need water to irrigate the crops to grow. So it is not like saying, okay, we're not going to use the water, we're using too much. Maybe we cannot go below that threshold. It's just below too much that threshold, but it's just saying that probably we have to be more careful in the way that we use the water. It's just not saying don't use, we need it. Yeah, but water then, we have to be more careful how we use it. And we're going to use more because we need to produce more food. So we really need water. And water is becoming, or not becoming, it's always been, it's been the cause of wars. And we know that a lot of people will live in stress areas quite soon. So we need to take care of this. And something that really illustrates how all this is connected, and we can't just look at a glass of water, is to look at this hidden water. This water footprint of food products, just looking at food. This is an example from the UK. You get this from the net. Say that one person, this is the number they got to, spends 3,500 liters of water a day. And you say, okay, but how much do you know that you use from your tap? Probably in UK, I think it's about 200. We're below 200 liters. So where's the rest? How do you do this water footprint? I think this is a nice exercise, especially for students, because in a house, most of it you use for bathing and showering, not for the cooking or for and drinking. Most of it goes for the bathing and showering. Of course, it's not the same as I say in all countries. But then, so where is the rest? This is only around. Here it must be the UK figure, 137. So most countries are around between 100 and 200. And it varies within the country. Lisbon and Porto, for example, are very different. The rest goes what is hidden in your commodities, paper, whatever. And most of it is in the food you eat, because you had to use the water throughout the whole chain. So this is what, when you talk about ecological footprint and water footprint, you're actually accounting for all the water you use, and most is in your food products. So it's more than 90% of the water we use was the water you had to use to produce your food products. And you can categorize this, of course. The higher you have the processing here, and not just the processing, the higher you go into the food chain, you produce more water. If you eat an apple, it's about 800 liters of water per kilogram. These are figures per kilogram. If it's for beef, it's 15,000, because you had to grow for so many years, you have to process, they had to eat the grass, and it accounts for all of that. And then there is coffee here. I'll give this example of coffee. It didn't make me drink less coffee anyway, but you only drink a bit. Coffee is one of the commodities that uses more water if you account for everything. So this is just to give an overview of the water that is not just the water you see on the tap, is what you use to produce your food. And also then, there is a lot of wastewater that comes. If you in a food industry, for example, it's the highest consuming sector that you have. Then of course you can also pollute if you do not treat your wastewater. And most of the water that is actually contaminated by the domestic wastewater that you produce. And also you can have the food industry wastewater and the agriculture. If you use 70% of the water in agriculture, water goes somewhere. So if you leach all the nutrients, the over fertilization that you sometimes do, even if you do not do over fertilization, it will end up in water, and you get eutrophication, you get it water hyacinths growing through. So all this is linked. And then you have the deterioration of the water resources, of course. And as I was saying, for the food industry, they are the sectors that that use more water, so produce more wastewater, and also they are producing the most highly loaded wastewater, lots of organic matter. So you can choose to, okay, I'm not saying that you can choose to pollute, but it can be a pollution problem or it can be a resource. And nowadays, people that are working in the wastewater, it's good to know, are not looking at wastewater. This is one of my fields as just a pollution load, but wastewater resource recovery, something where you can recover something that is good. And for the wastewater from the food, it's so loaded, you can treat it anaerobically, so you can produce the biogas. Or you can, people are looking at wastewater to recover phosphorus. So everyone is synthesizing nitrogen and phosphorus, and what you're doing in not synthesizing phosphorus, you can don't do it. But digging phosphorus, what are we doing in a wastewater treatment plant? Just destroying it. It makes no sense. So we really have to recover and also to connect water, energy and irrigation in infrastructure planning much more carefully. So people are producing bioplastics through wastewater, especially the food industry wastewater, because it's so much high content in organic matter. Just some examples: fish meal substitutes, fertilizers like struvite fertilizer extracted from wastewater. This is magnesium monophosphates, lots of phosphorus in there. Lots of things are taking the fat to produce biodiesel. There is a completely new world in the area of wastewater, and the wastewater that is more prone for resource recovery is the food industry wastewater. And no doubt we are going through this biorefinery concept for the wastewater, like we're doing in other sectors. And one big contributor is obviously the food sector, from agriculture to the food industry, which is much more easier to recover than industrial. And another resource that we talk about in this first class is just cover a bit soil, because soil is actually the foundation for food production as well. And we know, using the planetary boundaries, nitrogen synthesis exceeds the planetary boundary by a factor of 4, and you saw phosphorus already reaching the planetary boundary. And we need, the plants need the nitrogen and phosphorus to grow. We need to crop, and we need to do it in a different way. Also, agriculture is also, including fisheries, a big driver of biodiversity loss with the way we're producing the food, and also we're extracting a lot of water for irrigation. And soil is really one of the major resources we have, and it's very hard to produce in poor soil. But the figure is 70% of the Earth's land areas are substantially degraded. Erosion, loss of organic matter, depends on where you are. Compaction, decreased biodiversity, salinization, which has also to do with the irrigating with wastewater, for example. Contamination, all these contribute to the degradation of our water, our soil. And it's not only the nasty things that contribute to the degradation, is also, as we've seen, agriculture and forestry. For all the sectors, and this is something that the students then look during the semester. I only put this one for soils in this particular introduction, is intergovernmental panels. There is one for soils, where you join all the countries, because it's such a big issue. Soil was the year of soil for FAO, I think it was 3 years ago, the International Year of Soil, because it is such an important issue. If we do not have soil, we will not be able to produce good food. And we're losing a lot of good soil. And the key pressures that I started with, water, phosphorus, biodiversity loss, this has a lot to do with soil and the way we are using soil. So this is something we cover later on, to know the issues for sustainable agriculture, because everyone wants to have a high crop quality and a high yield, but it has to be in a way different from the massive production that we've doing in the past decades. We need to have low nitrogen losses. We need to have an agriculture that encompasses higher biodiversity, including pulses and legumes, to fertilize naturally the soil. People are already doing this, going back to the past practices. Low erosion, different agricultural practice, high biodiversity, including animals. We're going back to this, combining the agriculture with the animal production, and of course looking into the circular agriculture, where we actually take one thing to feed. There is a circular thing to feed the sectors, or to circularly feed. And it's not just going back to the what we're doing in the past, is to combine the ecological principles with the modern technology. It's precision agriculture. It's the smart agriculture for irrigation. It's not just let's do what we're doing in the past, because we just can't go back. We have to feed too many people, but we have to go back to the ecological principles that I truly believe that we have to do. Otherwise, we're just not going to be able to feed the world. Cropping systems are evolving nowadays, and many go back to crop rotation, to co-cropping. I don't know what you see in your countries. We are seeing a kind of a revolution here in Portugal. People are really going back to this, and this is something that I just use to say that something we do a lot. This is not a particular place. This is a picture of Quinta dos Mursas. Is a port wine producing farm where they do the co-cropping. They do the biological production of wine. This is in Douro River, Something we do in this course is to go to a lot of field visits. I did not go, I have to say, to this particular one with the students, but I always, every concept that we illustrate, at least we do 3 to 4 field visits. And then we talked about precision agriculture. It's just to show it's not only going back, it's looking at what we can, how we can combine the modern things. And then just to finish, food waste. This is something we always look a lot in the course because it's such a big issue nowadays. Well, I mean, probably more nowadays than in the last century. And during the food chain, we lose a lot, and there is a big difference between food loss and food waste. Food waste, you mostly waste through consumption and retailing, and food loss has much more to do with the food industry, the technology, and it has mostly to do with the production and the harvesting, the distribution. So all the gear that you have to allow for maintaining the food. So the packaging, the storage, the infrastructures. And I take this example to say that as for all the other issues, this depends on where you are. This so-called food that never gets eaten, which is a lot. And this is just to illustrate, used for this sector. This is different depending on where you are in the world. Your wastage, or what you waste or what you lose through the more technological part of food production is very much different. So I'll just go through the edges. If you are in North America and Oceania, you lose mostly your wastage is due to waste in consumption. You just buy too much and you let it rotten in your fridge or whatever. If you are in sub-Saharan Africa, then that is just 5%. You mostly lose through loss because you don't have the technological means to keep it. So this occurs through all it's like water, is like for all sectors. And this is a nice example just to say that it depends on where you are. And then your problem is different. What you have to solve is much different. But what is good to show the students so that they are aware, if you were to look at the greenhouse emissions that are produced or that are emitted due to the production of that food that you never got eaten, if you just put it on the greenhouse emissions chart of all the countries, the food wastage would be the 3rd biggest country in terms of producing greenhouse gas emissions. So it is a lot. So we are in the food chain contributing a lot to environmental degradation. So it's not just that we need a good environment to produce the food. We are contributing a lot to the gas emissions, to the deterioration of the environment. It approaches almost the levels of the road transport. It is a lot. If you look here of this global picture, where do greenhouse gas emissions come from? You see the cow here. It's very much, which does not represent just the cows, it's agriculture and land is by 5% different to electricity and heat. So, okay, even if you say, okay, these figures are not completely true, it might not be, but what we have to look at is the big picture. It's not just whether it's 20.5 or 21. It doesn't matter. It's just the pattern. You cannot deny this. We have to do it in a different way. Of course, if we waste the food, so we contribute to all those greenhouse production. So it was a missed opportunity, not only to feed people, but we contribute to deforestation. That's something we are not talking today, but you do deforestation to use land for other things, waste of natural resources. It all has to do with this global warming, climate change in the end. So this has to do with our everyday practices. If you go, this is another intergovernmental panel. This is for climate change. They produce reports every year. And this is one, maybe I did not put it right. So I did, this was the one I used last year for the last course. This does not change dramatically from one year to the other. What they recommend around the world to stop these greenhouse gas emissions, many of the changes are needed in agriculture or have to do with agriculture. Increasing carbon sequestration, improving the agricultural management of soil, fertilization is a big problem, methane emissions is a big problem. It has to do also with our diet and reducing food waste. This is just key messages. And if you go and look, we do need a more efficient use of resources that is more circular. We need to avoid deforestation, grow more on the farms we've got. This has to do with be more efficient users of what we've got. Shift diets. We don't need to go vegan. We just need to be more equilibrated, reduce waste. You can go and see that there are numbers on the impacts. You just need to eat a little less of meat, and then there's a big impact on the greenhouse gas emissions. And all this goes towards what everyone talks about, which is the circular economy. And this is in bed. I rarely use this as the driver for introducing these issues, because this should be embedded everywhere, the circular economy. We know it from the past. This is just common sense. Okay, filled with technology that allows us to do much more than what we were used to, because we do need much more because we are too many. So I think I put it in a very simple way, not make it too rough. And we have to do it from primary production for a circular economy, and we have to do it to the food processing stage. I thought it would be nice, don't take it badly, to use an example of ours, where we use the codfish. We are big producers of codfish, and we use the bones to extract hydroxyapatite. So we will not need to do the chemical synthesis. From then, do different bioproducts. We're doing sunscreen, a material for biomedical, and this is the kind of higher technology that is needed. There are some of the things you can do. You do need the technology. Others are more just common sense, and that you do it more in a more circular way. So I'm going to skip this. With this kind of introduction, what my main aim with the students in this course is that they have the big picture, because then I go deep in the subjects during the semester, because what they do in that particular semester, they have two other courses. One is development of new products, and the other one is packaging. And we work together, these three courses, in that particular semester. Other courses from other semesters also can have the technology, for example, the food technology. They develop a new food product, and they have to have into account the sustainability of the food product that they are proposing, either in the more efficient technology that is less energy user, or they're using pulses, they're using legumes to complement. They're using products that, for example, if they're saying, okay, we're using almond milk and not the cow milk, okay, but then they have to say where are they getting, because they are here in Portugal, if they have their plant here, where are you getting our almonds? Are you going to California and use the almonds that come from monoculture and it's being a big problem? Or are you taking that into consideration? They have to look into the whole chain. So they must be aware of the main issues from the beginning of the course, because then it's during the semester. Say if I didn't talk about waste until the end of the semester, then food waste, they would not be so much aware, because then we'll go on it, but they have this to be able to select what is more relevant to their product. And they do this project in development of new products. And they have to do this project, and they do assays for the 3 courses. I mean, I am assigning an assay that they use in 3 courses. And it's very good for them, because then they have the packaging course where they can get help for their new product, because they have to do the packaging, they have the marketing, they have all these components going through their product. And many of them, this is not the logo. I just put eco because of this course in green. They have to incorporate the eco aspects, and they go mostly, I don't know who's aware of that, it's an international conquest. They go for ecotrophilia then with these new projects, some of the group of students. And in the end of the class, I always do the poll again. And I ask, okay, so do you think this course makes sense in your food engineering degree? I never got by the end of the class someone saying, or not changing their minds that it makes sense. They're not going to be environmental engineers. They're not going to be constructing wastewater treatment plants. But they need to be aware of what are the things that we need to take into consideration when we are working in this sector. So I hope this was of any interest to you. It was not supposed to be a lecture. It was just to be like a conversation or me sharing. And thanks for your attention. It's a very blank one. I didn't have time to put a picture. I'm sorry. Thanks for your attention. If you want to do any questions, I'm available.
Thank you, Paula, so much. I should say that in nowadays, this topic is really actual, because the adaptation of food system strategy to environmental changes is really crucial. Yeah. And I think that it's crucial and important in terms of 2 concepts, like food security, nutrition, which is connected with human health. And second, I assume it is important in terms of poverty reduction. So, and I absolutely agree that there are lots of factors that affect on the quality of like greenhouse gases, like fossil fuel, like which are releases ammonia. That's why I thank you very much, and it is really, really crucial and actual topic.
Thank you. Thank you, Karen. It's good to be talking to other people that are not just the students, because I've been teaching this course, at least for the international master, I don't know, 8 years or, and it's in the beginning, it's the international students. They were people that were already, usually they are already working. This was Erasmus master that we have with Leuven and Germany. And it ran for 15 years already. They introduced this course, I think, after 5 years. And they were the students which much more receptive to the course was always, I always enjoyed much more at the beginning with those students. And they were already working. With the food engineering, that when we introduced in I also teach to the food engineering, our students, so the Portuguese students. In the beginning, there were many suspicious students, because they say, why are you there? Because they see me as the environmental person, and we're not doing a master in environmental engineering, we're doing a master in food engineering. So why are you here? So of course, it's things are changing now, and it's good. But yeah, I think it's I change a bit every year the course, but I think there is a much more awareness when they get to this stage. And I think the bigger awareness that I always felt in the beginning with international students was because they were already working. So they were more mature and they had already a feeling of what things were needed, how things were needed.
Yeah, for sure. For sure.
Yeah.
Thank you.
This is just the way I approach. It could be another approach. It was just, yeah.
No, of course. I agree. Thanks.
Dear Paula, thank you for a very interesting presentation. I'm sorry I joined in a few minutes later because of technical problem.
Oh.
It's a very interesting topic, and as Gayane mentioned, it's very crucial for Armenia because it's one of the priority, especially related to the sustainable agriculture, smart farming, and also is connected very connected with climate change issue.
Yeah.
It is pity, of course, that we have only 1 hour because it's not enough for such huge topic.
It is a huge topic, yes.
Thank you so much. We very hope that when situation will be solved, we will be able to continue some training activities face to face in Armenia, and you are very welcome to come.
Thank you. Thank you. There are some of the webinars that we're proposing here. I did not show any research because I do mostly research to do with water and soil. But the following webinars, I'll show some of the things that we do. I'll do 1 and 2 of the postdocs that work with me. We'll do 2 on soil, and I'll do 1 on water. But it is a very, as I said, I'm a food engineering, but I always been very enthusiastic about more about the environment. So
yeah, thank you so much. We will cover your next presentation with case studies you mentioned. Thank you.
yes, it is case studies. Yes. Here was more. I thought, okay, well, what am I going to do? Why did I say that I was going to do this? Maybe they're not. But then I thought, okay, I'll just speak about our approach, how I approach this in the master, because I think this project is all about this course development and the interaction to see how different people are integrating this in their studies.
Thank you.
Thank you.
Thank you very much for your attention.
Thank you.